Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have in our pipeline, click on this link. It's in the description. You will see other events we have in our pipeline. Then do not forget to subscribe to our YouTube channel. This way you'll receive notifications about all future streams like the one we have today. And last but not least, we have an amazing Slack community where you can talk to other data enthusiasts. The link is also in the description. Check it out. During the interview, you can ask any question you want. There is a pinned link in the live chat. So ask your questions there, and we will be covering these questions during the interview. That's the usual intro. I haven't done it in a while because I was on a break. But now it's back to school time, so now we're also back to our usual activities. And right now I'm opening the document with the questions. So Daniel, are you ready to start?
Oh, yes, I am.
Yeah, so let's start. This week we'll discuss astronomy, applied machine learning, and how you can move from one to another. We have a very special guest today, Daniel. Daniel is an astrophysicist, turned machine learning engineer, and AI ambassador. He's a PhD candidate at the University of Cape Town. He builds end-to-end systems and LLM applications with a focus on reliability and monitoring. His recent work spans knowledge retrieval assistance, evaluation, observability, applying data science to space, weather, and multi-wavelength astronomy. So this is really cool. I am really excited to talk about all these topics. So welcome to our event.
Thank you, Alexei.
Yeah, usually the first thing I ask about is about your career so far. But recently, I don't know if you observed this in the southern hemisphere. Recently, we had a lunar eclipse, and it was very, very cool because we had this full moon. But then the next night I see the moon is not full, and I'm like, okay, this is strange. Like it's supposed to gradually decrease, but all of a sudden it's just like a little piece of the moon, and I'm like, what's happening? But then it turned red, and I'm like, oh my God, what's going on? So I asked ChatGPT, how can moon be red? And then GPT says, yeah, it can be during moon eclipse. And like, okay,
Yeah, lunar eclipse.
when is the next lunar eclipse? And it says, yeah, by the way, it's actually today. And I'm like, wow, it was so cool. And now we talk
Yeah.
about astronomy. I don't know anything about astronomy except this lunar eclipse thing, because I witnessed with my own eyes that the moon can turn red. This is awesome. And I've been to our planetarium here in Berlin a few times. So that's my knowledge of astronomy. So I'm really excited about this talk today because for me, this is always interesting, but I don't know much about this. So really cool.
Well, thank you very much. Also, on my side, I'm going to say thank you again to you because uh, over the years you have been running this Data Talks Club, and to be honest, there's been a lot of value that has been created from it, especially with this concurrent courses that runs from January to end of the year. So I wonder how you do that, like how you're able to run these things, organize podcasts, bring people to talk about the new software development, and all that. So kudos to you as well for for pulling that off.
Yeah. Yeah, well, it's kind of my job now. So before it wasn't, so I was a data scientist, but now it's my job. So that's how I managed to do all that. But today we're talking about you, Daniel.
Okay.
Let's start with your background. Can you tell us about your career journey so far?
Well, my career journey, just like you said, I'm a PhD candidate at University of Cape Town. I only came to South Africa because of my PhD. I did my undergrads, masters in Nigeria, and then after COVID, I got a scholarship to come do my PhD here in South Africa at the University of Cape Town, also at one of the institutes here called the South Africa Astronomy Observatory. So generally, my work is on leveraging what we call multi-wavelength strategy to find radio emitting stars. So all of us know that stars is something that we see very common in the sky with our naked eyes. But that is because stars are very good at radiating in the optical wavelength, which our eyes can see. But if you go towards the lower frequency regime of the electromagnetic spectrum, it becomes very difficult to speak of stars, to see stars. So recently, there's a current project, I'll call it a global project or international project going on now called the Square Kilometer Array. So the Square Kilometer Array is one of those, I would say, gigantic science missions to build uh, arrays of telescopes, radio telescopes. It's going to be hosted by two countries, South Africa and Australia. So in the course of that project, South Africa bidded and they got the hosting rights to host a part of the SKA meet. So that prompted them to build this precursor telescope called MEERKAT, which is a um, 64 antenna array sitting in the Karoo Desert in the Northern Cape. So after launching the telescope in 2018, there was this legacy data set that was taken about the galactic plane. So the galactic plane is just that patch of the sky that is very, very dusty. If you look at the picture you guys used in my for this ad, you're going to see in that picture a patch of the sky, what we call the Milky Way. So that is the galactic plane. And in 2018, from 2018 to 2020, MEERKAT mapped this whole portion of the sky. And my job is to now take the data from MEERKAT and find radio emitting stars from that data set. So
Find
that's,
find what?
yeah,
Sorry.
find radio emitting stars.
Uh-huh. So
Yes.
what is it? So I'm a very lay person when it comes to these things. So physics wasn't my favorite subject for some reasons in school. I don't know why. I liked mathematics, but not physics. So what does it mean, electromagnetic spectrum?
Oh, well, so the electromagnetic spectrum is basically the regime by which light can emit in. So you have it, it can be low frequency, high frequency, or wavelength related. So it spans from radio, which we consider low frequency, to high frequency to like gamma ray. Yeah.
Okay.
So you have X-ray and gamma ray. So these
Hmm.
things are quite, this tells you more like the intensity or the energy range of the photon. Yeah.
Hmm.
So our eyes can only pick up things in the optical,
Hmm.
right? But
Okay.
yeah. So but at the same time, things like the communication channels, like radio, or we talk about antennas, Wi-Fi, they all operate in the radio region. Starlink, telecommunication devices. Then you begin to talk about gamma ray. You're talking about maybe okay, X-ray. You can talk about X-ray, some of these X-ray devices and stuff like
Okay.
that. Yeah. So in astronomy, we also build receivers. Astronomers also, in astrophysics, we build receivers for picking up these emissions at different wavelengths. So in the optical, you have the most common telescopes, even the basic ones that you see people buy. You can buy from Alibaba, you can buy from Amazon. Those are basic ones. And also even big ones like we have here at this SAO facility. But then things like radio, it's
Mhm.
not so common. So you need to build it in a very quiet field because you also want to avoid radio interference from electronic devices or from satellites. And then for X-ray, it's not so convenient to build them here. So you have to send them to space. You have to send satellites, telescopes in space. You have a couple of them.
Mhm.
Like the most common one is the one from your country. Are you from Germany, right? Okay, you're based in Germany.
I'm
So you
based
have
in Germany, yeah.
okay, we have the eRosita project currently ongoing. It's a collaboration between Russia and Germany.
Uh-huh.
So it's also a
Okay.
space telescope that operates in the X-ray.
Mhm.
Yeah.
And James Webb Telescope is
Yeah,
optical, or what is it?
James Webster is also a space telescope. It operates in the infrared. Yeah.
Infrared.
Yes.
Okay, so many things. But infrared is something we don't see, right? So when I go out, well, in Berlin, the sky is not really visible, but let's say there is not a lot of less light pollution. So I go out, turn my head up, and I see stars, right? So this is just the usual light waves, right? That go from, I don't know, um,
So the infrared is quite
red
close to the
to
yeah.
violet, right? So the usual range.
Infrared sits in
Yeah.
more like
Okay.
lower frequency compared to the optical.
Hmm.
Yeah, but it's very near to the optical.
And
Yeah.
this electromagnetic spectrum is we have devices like my mobile phone,
Yeah.
like Wi-Fi router, but stars also and other I don't know space bodies. They emit some
Yeah, they
electromagnetic wave,
actually
right?
they emit in multiple wavelengths.
Hmm.
Yeah, but the only thing is that sometimes the strength of wavelength is not able to reach us here. Yeah, it's only
Okay,
optical that is usually
understood.
very, very dominant,
Hmm.
or less X-ray in the case of maybe black hole systems that like have black holes. You can say, oh, these
Hmm.
are very, very energetic systems. Yeah.
Hmm. Because black holes, they don't emit light, but they emit something else, or they don't emit anything.
Well, yeah, not optical light, but there's a whole lot of activity there that is very, very energetic. So with that, we are able to pick up even X-ray and gamma ray events.
Okay, okay,
Yes.
interesting. And what do you exactly do? So you said there is this MEC telescope, right? Or
So
this,
what I do is that we have the MEERKAT data, the collected data of the galactic plane, and then also able to like identify the point source or compact source points in this object. So our job is to say, given the fact that we have these data sets, we need to find how many of them are emissions coming from stars and not from other um, extragalactic or
mhm,
astrophysical objects out there, because usually in the radio you tend to pick up mostly extragalactic sources, AGNs,
mhm,
galaxies, and the rest of them because they are very strong in the radio. Than
mhm,
yeah. So, but at the same time, we know there are a couple of stars too that also have
mhm,
radio emissions that we can pick up, especially with new instruments that are coming up, like MEERKAT or in Australia, SCAP or
mhm.
the VLA
Okay,
telescope.
so your job, if I understood, so you scan the sky, at least the Milky Way part, right?
Oh,
And
well,
you get some
so
signals.
the operation of MEERKAT was to scan the Milky Way path and then
Yeah.
get this data. And then my job is to now take this data derived from MEERKAT and do cross correlation with other multi-wavelength data sets.
Okay.
Yeah.
And the task for this particular project, if I understood correctly, so you have this scan of the sky with the of the Milky Way, and there are many sources of waves of radio
There are many
radiation, right?
detections of sources.
Yeah,
Yeah.
yeah. So then you
Mhm.
need to understand if this wave is it coming from a star or it's coming from something else, right?
Yeah, exactly. Yes.
Uh-huh. And so you use machine learning for that.
Oh, well, not necessarily. We didn't use machine learning for this. We used cross correlation method, which is more like, the nearest neighbor concept. Yeah. So because you
Right.
have to also take into account the positions in the sky.
Mm-hmm.
The same way in geography here, we know our positions on Earth using the longitude and latitude. We also have it for the sky. So even though you are observing at different epoch, you need to
Mm-hmm.
also, enter in the correct position. So given the position that we have with MEERKAT, we go to other instruments like the European Space Agency Space Telescope. They also have their own space telescope mission called Gaia, though I think it
Mm-hmm.
stopped operation this year. It also has its own optical data. So at least the one we can
Mm-hmm.
see with our eyes. So comparing that positions, and
Mm-hmm.
then we're able to align which star which source actually has a common emission or
Mm-hmm.
detection in these two instruments.
Why do we need to look in this electromagnetic spectrum? Why is light not enough?
Okay, well, so like I said, we're looking for stars, and stars are very weak in the radio. So, but in the
Yeah,
optical, you have a lot of stars. Now you need
yeah,
to connect, okay, from the radio, the emissions,
yeah.
into linking the emissions, whether it's from the same star. So
Mm-hmm.
this is why you have to also cross correlate the positions. So
Mm-hmm. Yeah.
if you match the positions and you see, oh, this are actually falling from the same
Mm-hmm.
position, they begin to
Yeah.
check, okay, at least it raises the probability that this emission might actually be coming from the same source. But that is not
Mm-hmm.
enough. You begin to think about other possibilities because you are dealing with a 2D space. You're
Mm-hmm.
dealing with a 2D space. You're not dealing with a 3D space. So you don't have the stars information, or you also have a case whereby you can have a background and foreground object. Is it, for
Mm-hmm.
example, let's say you have how will I say this? So let's say you have this, right?
Mm-hmm.
And then you have this.
Japan.
Yeah,
And
so you'll be able to see this, right? You'll not be able to
yeah,
see it. Yeah, but the thing is
yeah.
also depends
For
on
those
the,
who are listening this, because we will release this later as audio-only podcast, you were showing a pen, and behind the pen there was a piece of paper, right?
yeah, yeah. So if you bend on you're looking, you first of all see the pen, right?
Yeah.
Good. And then so let's say they all have the same. If you look at if you look at the pen, you might
Hmm.
probably assume that, oh, because we are from a far distance, that the pen
Uh-huh.
and the paper are in the same position, but they are not actually in the
Uh-huh.
same position,
Yeah, yeah,
right?
I understand.
Yeah.
Okay, so this is when we observe light only, right? And the radio signal may tell us that actually like these are quite distant object. Just one is on top of like over how to say overlays. One covers another, right?
Yeah, one covers another.
Uh-huh.
Yeah.
And
So
in
you
Milky
have
Way, I guess it's a common problem because we have so many stars there.
here you have so many stars, thank you.
Yeah.
Know that.
Uh-huh.
So you have to now take that into account. And then, so even just finding that things are in the same position is not enough. You begin to think of the physics.
Hmm.
What are the properties? What are the known properties of the source based on previous observations? And then that can help you tie that the radio emission is actually coming from the source and not from a background object.
Okay,
Yeah.
I understand now.
Mm.
When I told you at the beginning that I have visited the planetarium here in Berlin. And in the planetarium, I think the show was about stars. Anyways, so they were showing what is like what do we see what we see in the sky,
Yeah.
and they showed the Milky Way. But because Milky Way is so dense, we cannot really receive the light coming from, I don't know, some galaxies that are
Yeah.
behind Milky Way. So
Mhm.
our map of the universe is limited to
Skewed.
things outside of Milky Way. So from
Exactly.
outside of Milky Way, we can detect light coming from like some galaxies, right? But because Milky Way covers or hides other things, we don't really know what is behind the Milky Way,
But that's
right?
because you are looking in in the optical wavelength.
Yeah, yeah.
So in the optical wavelength, you have this issue.
Mm.
And
So
this is, but in the radio, it's a different thing
mhm,
altogether.
yeah, yeah.
So the
So
stars are very dark in the radio. So
mhm,
if you point to the same place where I see a lot of stars in the radio, you're
mhm,
not going to see those stars anymore. You
yeah,
only
I
see those
understand.
background objects here.
Uh-huh.
Yeah.
And potentially, with the research you're doing, we will be eventually able to uh, extend the map of the universe we currently have to include like galaxies that are behind Milky Way, right? The
Oh,
one
of course,
we
yeah.
cannot
There are a
observe
couple of
right now.
people. Yes, of course, that is what MEERKAT was able to achieve with those galactic
Huh?
planes. So there are people, a lot of people looking at those background non-galactic sources within our galaxy. Yeah. What my job is just to look at the data and find galactic sources, at least the ones
Hmm.
that are radio stars, radio emitting stars, not extragalactic.
Hmm.
Yeah.
Yeah, very interesting. Very interesting. Thank you for sharing. How do you use machine learning? Do you use it in at your work right now?
Oh, no, no, not really. But we're building up a data set that could actually be very useful for machine learning in the future. Because, like I said, what we have currently is more of observational data. So you need to also build the physics from the observational data before diving into machine learning.
Yes,
Yes.
it's more like modeling right now. So there is some uh, data you observed or you
Yeah.
collected, and
Yeah.
then you try to, I don't know, use some formulas from physics to understand how this data
Exactly. Yeah,
happened.
we're
Okay.
doing the physics. Yeah, doing the
Hmm.
physics, giving the interpretations and making sure you're getting reliable data because you
Hmm.
need to get enough reliable data to be able to find.
Hmm.
Yeah. So let me give you a shocker.
Hmm.
At least over the years, we've had both ground and space-based telescopes that operate in optical. Like I told you, the other one is Gaia. Those stopped
Hmm.
operation earlier this year or late last year. Gaia mission had more than 1.8 billion stars.
Hmm.
Its survey. And
That's a
we
lot.
found stars. Yeah, stars in its survey. So this telescope was able to map the stars,
Hmm.
1.8 billion stars. And we have it in the data set.
Hmm.
And if you look at even in the infrared, you're going to pick up close to a billion stars, like two mass-wise, hundreds of billions of stars. Then even ground space telescope, like even CTF and the rest of them. But in the radio, we only have a few thousands of stars in the radio.
Hmm.
So you can see it is very, very, it is a short until recently, it was less than 1,000 radio stars, right?
Hmm.
It was less than 1,000 radio stars. So the reason is because the radio infrastructure is not as common as we have in the optical, because these are very these are high engineering, and again, they cost a lot to build compared to optical telescopes. So, but
Mhm.
recently, investment are now going into some of these things, and also building sensitive telescope that's able to pick up even very faint detections and micro Jansky. So it is now helping astronomers to at least resolve potential candidates of what we might call radio stars that people have thought about that, oh, given that we've seen this emission in the X-ray or in the optical, this kind of behavior, we're expecting that there should also be a radio emission coming from the star, right?
Mhm.
Yeah, it's for the nearby universe or within our solar neighborhood, we should be able to pick up some of these things. And that is what the whole SK precursor telescopes are doing with right now. Like I say, MEERKAT in South Africa, ASCAP in Australia, and VLA mission in the US.
Mhm. Mhm. Okay. So right now it's a few thousand of stars only, but with the investment in the hardware and technology, we should be able to observe more and more stars with this
Radio
method.
stars, yeah, radio stars, of
Hmm.
course. Because again, these things do also they do other science projects, not just for stars. They just the dominating field in the radio astronomy is extragalactic, like those
Hmm.
called AGMs, um, even galaxies, extended
Hmm.
objects, supernova remnants, and the rest of them. It's just things outside of our galaxy.
Hmm.
Yeah. Mm.
How did you actually, so you said what you use right now at work is more like statistics, correlation, then also physics, more like traditional modeling. At what point and how did you come across machine learning and decided to use it?
Well, so coming across machine learning was a thing that happened sometime, like say, I'll say probably during my master's or so. So I would say this, I have a friend who is an engineer. We also grew up together in Nigeria, and then he left for Canada sometime, and he was able to build so he studied electrical electronics engineering, and then he was able to build this AI startup called Ubenwa
Hmm.
way back in yeah, I'll say sometime around 2015, 16. And
Okay.
it was an AI, then it wasn't necessarily AI, it wasn't necessarily like a trend and stuff. So
Hmm.
AI that diagnoses infant asphyxia.
Hmm.
So this happens by analyzing the infant cries of babies. So being
Hmm.
able to use that to predict if an infant has asphyxia. So it became a motivating factor, but at the time it wasn't necessarily my thing. But getting into doing this program, I realized that I need to do a lot of data. I need to I have a lot of data, and this data is actually very, very huge. You're talking about tens of gigabytes. So you're not able to process this on your PC. You need a cloud, you need a cluster to process this data. So that is where the
Hmm.
whole data science concept came in.
Hmm.
So when I started my program, at the same time, there was an announcement, a program called um, Black and Brilliant AI program, organized by some people in the US and also in collaboration with Code Academy, because I was also struggling to learn, how to code in
Hmm.
Python, how to do data analysis, because I already know I'm going to deal with a lot of data
Hmm.
and you need to get hands-on in all of this. So I applied for that program and then I got accepted. And in about 3 months, we had this whole coding phase with Code Academy. It's the
Hmm.
platform and it also provided me with a couple of mentors. So with that, we're able to interact. There were also conversations around machine learning because a good number of them are practitioners. They're already like in the industry, tech industry. Not some of them are not necessarily doing machine learning, but they are like, things related to machine learning. So one of my mentors who happens to be was also a machine learning person, like said, all motivated about how data science is. I already know the impact of data science in my field, but it was also trying to like buttress why I should not look at it from the prism of astronomy alone, but also look at it from the prism of the fact that I'm able to understand the concept of data analysis and
Hmm.
also employing um, programming tools into it. Because again, the idea was that if you're able to do this successfully within your academic field, you can also do it. It's actually the same paradigm in the industry. So
Hmm.
that became a motivator. And at least that I started also getting my hands dirty. And instead of
Mhm.
using some software to do the cross matching or cross
Mhm.
correlation, I started trying using AstroPy. So in astronomy, we have the Python package called
Mhm.
AstroPy. It is very, very robust. It actually incorporates, I'm going to say it incorporates a number of things from pandas, NumPy, to even start, yeah, SciPy together, all together bonding into one. So the
Yeah,
idea
I'm
is,
looking at it right now.
yeah, so it's
Interesting.
yeah, it's the go-to package for doing anything astronomy related in Python. So
Mhm.
I started, trying that out, started combining my data with NumPy because, like I said, the data was very, very old. So even using pandas was not going to work. But
Mhm.
AstroPy allows, like, the whole flexibility of dealing with big data and all
Mhm.
that. So I started seeing how I could actually manage all of these things together. So that's where the
Mhm.
whole thing, like, oh, this is actually beautiful. I could do this. And I'm also glad that I didn't have to also run these things on my PC. So I actually had access to like a cloud service or cluster where I could just run things on a Jupyter Hub and keep running day to day. And then yeah. But then in 2022, that's when I think it was one of the mentors who reshared your post about your advertisement for ML Labs.
Mhm.
Not
That was
was
the
it
MLOps course
data,
or
no, data
ML
engine. Initially, it was data
data engineering.
engineering.
Okay.
Yeah, data engineering. So this was January 2022. So I signed up for the data
It was
engineering.
the first one, the
Yeah,
first
yeah.
edition.
So I signed up for the data engineering. By the time I was traveling, so I wasn't available to do all of that because again, I was just starting in Python. Then there were a lot of things were now like heavy. You're now talking about cloud. I'm like, okay, Terraform and the rest of them.
Mm.
Like, but
Yeah.
one of the motivation at the time was that I was not stable, so I was just trying to do and I was traveling, and then at the same time, I was just starting my PhD, so I need to like to do get some results and get my hands dirty. So I had
Mhm.
to skip it. Then later that year, that's when the ML Zoom camp came in, and then
Mhm.
I had to take the ML Zoom camp. And yeah, I would say that was the eye opener on the machine learning perspective. So
Mhm.
when I eventually finished the machine learning
Mhm.
course, like I think for more than is it 8 or 10 weeks, and
Mhm.
one of the rules was that you need to share your learning
Mhm.
things. And so I was sharing. And one of the reasons why I was sharing is because a lot of the people who were my mentors or part of the people who were mentors in the Black and Brilliant, we connected on LinkedIn. So most times I
Mhm.
do ask them questions, really those who have background in like the science and machine learning. So they started seeing what I was doing, right?
Mhm.
And so with that, they like, oh, you're doing a good job. So they keep encouragement. Sometimes one of them will send me a
Mhm.
message on WhatsApp. Oh, I see what you're doing. Keep it up. Keep it up. You're doing
Mhm. That's really cool.
fantastic. Yeah. So that's how the whole team started. I'm like, are you serious? This thing I'm doing, I'm thinking I'm just trying to like get my hands dirty, and then somebody is like telling you you're doing a good job. So that's just where the whole machine learning thing,
Mhm.
I would say, kicked in fully. Yeah.
Mhm. So you took it in 2022, right? The
Um.
ML course.
Yes.
Cool. It was,
Mm.
I think, our second edition of
Okay.
ML ZoomCamp.
Yeah.
That's really cool. Yeah, thanks for sharing that. Does it help you, like, because you said you don't really use machine learning, you use other things?
Oh,
Well,
well, yeah.
uh,
So,
I'm
yeah.
wondering if what you learned is helpful at your
Okay.
work.
Yeah, of course, it is helpful. So, okay, first and foremost, let's not even just talk about the machine learning aspect. Just talk about like the paradigm shift in the coding experience itself. Because initially, when I started learning Python and even like who data analysis, data science, it's mostly everything is just done on a Jupyter notebook, right?
Mhm.
Even like I said, even testing, getting my hands dirty on the Jupyter Hub server that we have,
Mhm.
everything runs on Jupyter Notebook. But taking the ML Labs Camp allowed me to now shift from just writing codes in Jupyter Notebook to like writing Python scripts that are reusable, right? That can be used for like doing other tasks later. Because let me tell you something, it's really in the whole a whole lot of the science field is a lot of people don't, unlike maybe computer scientists, a lot of people don't learn Python like from a developer perspective.
Mhm.
They just learn for doing their basic task, right? Okay, oh, I'm a scientist, I need to do this analysis. Maybe I need to do this plot. I just do it in the Jupyter notebook, the lazy way of doing things. And it stops there. Even
Hmm.
senior researchers or stuff, they only just know how to do the whole Jupyter because this is all like the UI thing where you can just see your results, save them, and then you go away. So the ML Zoom camp was like an eye opener to say, no, actually, you need to think about developing your project. Think about implementing models that can be used in real life or like in the industry or for inference, just like you say. So that is where the whole idea, stepped in. And that's when I started doing the whole like GitHub repo project,
Hmm.
writing script and sharing them and this making them reusable and the rest of them. So yeah, taking that was also very, very essential. Like I said, then the introduction to cloud service, right?
Hmm.
Because I know even though here we have the data cluster, it's also a cloud service, but doesn't even have an idea what happens behind the scene, you understand, and also how to do all that because it's all set up in a way that you just go and jump in and use. So those some of those steps that you have to do, even Terraform, even
Yeah.
doing things in the cloud where you have to like even set up like virtual environments or setting up your Docker in a cloud. So those are like small add-ons. Even though I
Hmm.
know in astronomy we tend to use a lot of Linux a lot because we also have other softwares that allows it. So I was very familiar with doing the bash scripting, right? But not like doing Python scripts and just calling them over and over again. Yeah. So
Hmm.
those are some of the takeaways. Yeah, but in addition, it also opened a lot of opportunity to me because in 2023, OpenAI came up with the ChatGPT, right, in
Yeah.
late 22. And then in May 2023, one of the mentors reached out to me and say, I see you're progressing very well, especially when I finished the ML ZoomCamp course and got a certificate, so I shared it. And then it was reached out to me and say, will you be willing to work on an ML project as an intern? I'm like,
Hmm.
what? He said, well, I understand you're a student. I don't want to distract you, but this is just going to be like something minor, a few hours a month. We can make arrangements so that it doesn't affect you. I'm like,
Hmm.
okay, that's a good deal. So because he was setting up a consulting company in the US,
Hmm.
and that's how it kickstarted. So my job was to do um, testing out deployment of Intel, there's this Intel product called OpenVINO for edge devices. So the idea then was to see how to
No,
deploy
it's
some of the,
some computer vision
yeah,
thing,
computer
right?
vision, yes. So the idea was to test out a couple of the models. You have, I've forgotten all of them now, this was way back. So, package them and deploy them on
Mm-hmm.
Intel Cloud, so Intel hardware. They do have a
Mm-hmm.
couple of GPUs at the time, or their own set
Mm-hmm.
of hardware, but CPU, there are different sort of compute resource. So that is what I was doing because he works with Intel. So more like, okay, we need you to do this, we need to test these things out. And that's how I started doing it. I started saying, well, getting the essence of how, you need to actually deploy stuff in a like different set of hardware, think about throughput and latency and the rest of them, and even figuring out, okay, what is the right infrastructure for deploying your service. So we did that and it worked. So I usually just run the whole prototyping and then just hand it over to him because he has other people in the team. So my job was just to quickly test out something. And then later on, LangChain came into the scene. And then,
Mm-hmm.
people started talking about AI, LLM, and the rest. So he said, I know you just started doing machine learning. AI, deep learning is not something that you're very good at, but if you think you want to test the waters, you can check out. So he did share me a couple of sources. Have you heard about LangChain? I said, well, I'm not so sure. I was like, Google about it. So I started reading about it. I was like, oh, because then I wasn't paying attention to that area. So now I realized that, okay, we are now in an era where you can actually use these models, especially the open source models and Hugging Face, try them out. So like, okay, get an Hugging Face API and then started trying things by myself. And so that's how that whole step started into moving from classical machine learning to thinking about AI application like LLM prompting and
Mm-hmm.
essentially RAG. application, thinking about embedding, thinking about vector database and the rest of them. So we're just always prototyping as new
Hmm.
products coming or new frameworks coming, because they were like, you need to get a sense of also testing on their infrastructure and maybe see for also some of the maybe I would say clients he was servicing with his consulting company. So I was going through all of these things, and to be honest, it was challenging. At the same time, it was fun because somebody trusting you even when you don't necessarily have like technical know-how, at least to do all of these things. So it became more of a thing, yeah, until at some point we had to stop when Intel's problem, the time Intel had to, there's a lot of issues, I think last year, maybe it was a thing in the news. So we had to stop. And then I had to concentrate, go back to my studies because I was also thinking about, okay, after all of this research or analysis that I've done, we need to put them in a paper, at least
Hmm.
academic paper. So I had to like stop that and
That makes
until,
sense.
yeah, early this year
Focus
again, we're
on
like,
graduation.
yeah, yes, we needed to like, do all that. So that's just
Hmm.
how my journey has been in the space.
Yeah,
Mm.
that's pretty cool. And did I understand you correctly that they reached out to you because you were sharing your progress during the course? They saw you on LinkedIn, and then at some point when they had a project, they reached out to you saying, I think you say 2023 May, they reached out to you saying, hey, do you want to work on this thing?
Oh yes, like I said, because I already knew this person as a mentor during the Black and Brilliant. So while I was sharing my progress on LinkedIn, he was like, "Okay, I see you're now taking machine learning seriously." So I do get like messages like, "Good job." And one of the reasons why I was sharing my learning this thing then on LinkedIn was because I know I follow them. I also wanted the people in my circle who I think are way better to also maybe share their thoughts about maybe what
Mm.
I need to do, because that's what I usually do then is that maybe if I'm learning something, I can maybe reach out to somebody I think and say, please, what do you think about this? Do you think it's a waste of time? Do you think it's worth it? So I got that encouragement a few times, and then in May he was like, okay, if you can do this project, then can you do
Hmm.
this? Or if you want to try, you understand?
Hmm.
Yeah.
Yeah,
So
that's
that's
really cool.
how. Mhm.
Because in our courses, we usually encourage course participants to share in public, but many don't do. Many still continue doing this silently, which is okay. Not everyone wants to share. But I want to encourage as many people as possible. And your story is really good. So if you don't mind, I want to use your story to encourage students to say to share things, to share their learnings publicly.
Yeah, I
Um,
do. To be honest, I tell people to do that a lot these days because I'm also mentoring people. So irrespective of how basic what everything you've done,
yeah,
just say it, no matter how
yeah,
little. Just say it because again, it doesn't have to be about praises or people telling you well done. It should
hmm,
be also be about somebody might actually just make a suggestion to you. I've
hmm,
seen a post where somebody have made something. I feel like I see this is a beginner. I made a suggestion to them. You understand?
hmm,
So I know there was somebody who was just trying to share something around machine learning. He was just a beginner asking questions. So I was reading this, blah, blah, blah. I said, you know what? Go to YouTube, go and search for ML of ZoomCamp. So
hmm,
actually, I've like encouraged a lot of people to enroll directly
hmm,
into the ML ZoomCamp. Why? Because it's important that you learn the best practices, which is something that I think was missing then. Most times, if you go to things like Coursera and stuff, you don't see the sort of foundational thing like the whole end-to-end process. You understand? So everybody can come and teaches you machine learning, teaches you, okay, oh, you need to do, the sort of functions you need to call, type of models. But then nobody talks about deployment.
hmm,
Right. Yeah. Nobody talks about deployment. People then like ML ops, because again, even though remember you didn't necessarily call the ML Zoom camp an ML ops team, but at least it was at least there was call it's an end-to-end project, right?
yeah,
Yeah, because you're able to like train your model, evaluate the performance of your model, and then you deploy it. which
Mhm.
is not something that was so common at the time, especially for
Yeah.
like looking for free resources online. It wasn't
Yeah.
something common. And I felt like instead of wasting a lot of time, people can actually come, do this because this is how you actually enhance your programming skills,
Mhm.
doing those tough tasks. Because at the end of the day, it's a pattern, right? If you're able to figure out the pattern, then things will be able to move
Yeah. Yeah.
safely.
Yeah, that's why when thinking about the course, I really wanted to make sure this is a machine learning engineering course. So we have a lot of, we cover a lot of deployment strategies. We talk about deployment because many courses don't. And then people who graduate from these courses, they go to work and then they need to deploy a project and then they feel stuck. So and I saw this with my own eyes. So that's why I thought it's really good to create a course that focuses on that. Mm.
Oh, and I also took the recent ML Labs Zoom camp.
Okay, okay, good.
Yeah, I just completed. So in that case, I didn't have enough time because these days I'm also very busy. So if I tell you
Yeah.
I only just take those courses during the weekend,
Hmm.
you understand, and did the project, I was like, no, I need to do the projects. So I did the
Hmm.
projects and make sure I was able to get my
Yeah, yeah.
certificate. So, but I didn't share a lot of things. In short, I'm not sure I even shared anything online because I was also
Mhm.
like very, very on a very tight schedule. Again, I didn't want to
Yeah,
also share it to draw attention, like you've left your academics and you're doing this at this critical time.
I
So
see, I
yeah,
see.
yeah. So
So there are sometimes cases when you don't want to share your learning in public, right?
oh, well, yeah, of course, especially if yeah, I recommend majority of the time you should, but like in my case, the reason why I didn't share it then was that I
You're
was in
busy.
between a couple of projects and you don't want
Hmm.
to feel like you have a divided attention. But again,
Hmm.
I had this born desire, I need to actually do that course and
Hmm.
get the
Yeah.
certificate. So because
Hmm.
that's lingered for
Yeah.
long, 2023, when I got the ML Zoom camp, I haven't gotten the next certificate. I was like, no, I have to do this. I actually registered in the data engineering Zoom camp at
Hmm.
the beginning of the year. I actually went through it end to end. The only problem was that I didn't submit the project. Like I didn't
Hmm.
submit the first, even though I did project because beginning of the year too was like I usually like have these activities, a lot of activities like
Hmm.
volunteer engagement and all that at the beginning of the year, even observation time. Sometimes we'll like sit down, which is also what like you have to use the telescope sometimes, like do observation run for like weeks. So you work at night and sleep during the day.
Hmm.
So,
Oh,
and you need
I
to pay
see.
attention to your observations. So those times are not usually convenient for me to do
Uh,
any other things. Yeah.
Yeah. Well, if you have a bit of free time, you can just submit your project in the next iteration, not do any course, just focus on
Oh,
the
well,
project.
yeah, okay. I actually just did another one, this time using Airflow.
Okay, yeah.
They
So
did
you can just
end-to-end,
do
Lean
that.
IO, the whole thing, all integrated.
Uh-huh.
Together. Yeah. Yeah.
Can you tell us about any of the projects you did for the courses? Maybe, like, for example, this one. Uh, it's I don't know if it's for a course or not, but the one you mentioned right now, Airflow and Mean.io.
Oh,
Is it
well,
something
so,
you
so,
did
so yeah, so it
work
is
for?
recently, yeah. So I, because I usually just sit down sometimes and say, what are the unfinished project that I did and what is more relevant? So during the data engineering Zoom camp, the one at the beginning of the year, so I remember the registration was Kestra. And
Yeah.
I did use Kestra. I did the whole thing of running the whole process from using Terraform to create your computes, your
Hmm.
big query because we use Google, right? And then setting things up and make sure they are running, and also querying data, doing the whole ELT transformation and putting them in Google Query, BigQuery. And I use Kestra for the orchestration.
Hmm.
But then I was speaking to somebody, like I said, sometimes I like to like consult with people in the industry to figure out what's actually the major trend. So it was like, friend was telling me, no, Airflow is still the number one orchestrator for running this thing. I was like, if you can try. I'm like, okay, I think I've tried Airflow for once, but I'm not sure I understood what was happening. So I just sit down last weekend, you won't believe it, and then I like, okay, setting up Airflow 3.0.
Hmm.
And to be honest, thanks to there was a president, that's thanks to there was one of the presenters in one of your show. I don't know if it's
Hmm.
what's called again, who talk about Airflow 3.0.
Hmm. Yeah, yeah.
So that's one of the resources I used, I believe it, to
Okay.
just set up the Airflow
Hmm.
3.0 on a Docker
You used
Compose.
Astro right? This is
Huh?
the command line. You use this command line utility from Astronomer for setting
Oh
up Airflow.
well, oh yeah, yeah. So actually, I tried using it, but unfortunately, I didn't succeed because I was trying to connect Spark,
Okay.
the other things to it. It did. I don't know. I think, like I said, I was in a hurry, but I figured out how to like do all of those things with just Docker Compose without using him. But I think the CLI is very, very nice to set things up.
Hmm.
Yeah, but yeah, finally, if everything worked last night, the whole end-to-end MySQL. So I did the whole thing of think about querying the data from a source, right, and putting it in your data warehouse. So in this case, I didn't want to connect to a cloud service, although I know how to do that, but I had to use MinIO to simulate the data lake, sorry. Yeah,
Yeah.
that's the data lake. So take data using my SQL, put it into MinIO, and then
Hmm.
also do PySpark for
Hmm.
maybe transformation, and then also save it in MinIO, and then take the data from MinIO, transform it into PostgreSQL, like where you have like analytics. Yeah.
Hmm.
So what I still have to do now is to employ DBT.
Hmm.
Yeah.
Okay.
And then just
Yeah, you're almost done. Then you can just submit this when we start the course, and then you'll get your certificate.
Oh yeah, yeah, yeah. So I'm actually thinking of then writing if maybe probably think of writing my first Medium article because I've not written Medium article. I know I've written something on LinkedIn because to be honest, the whole integration right now is not out there. Like
Mm.
encompassing Flow 3.0,
Yeah, I
PySpark.
imagine that it wasn't super straightforward. You
Yeah,
need.
I was searching on YouTube. I couldn't figure that. I couldn't find. So I had to struggle. But now I figured out how to work. So I think it's just going to be one of those things I'm
Yeah,
going to do.
please do. You'll save time to many people. But this is also kind of the essence of the data engineering job, because you have some things you need to figure out how they work together, and sometimes you spend a lot of time doing that.
Yeah.
Uh-huh.
Yeah, so it was a combination of looking at mostly people using Airflow 2.0, and then because that's why you see a lot of them use PySpark. But then the 3.0, there's a whole lot of glitching
Mm.
and differences. So I had to take my time to figure that out. Yeah, writing the Docker Compose, also setting environmental variables and parameters in the Airflow
Mhm.
web server to make sure things work. Yeah,
Mhm.
so it's just one of those, learning phases that we just do, especially when I feel like, not like I have time, but when I feel like I have my free time, I
Mhm.
just hop in. Then other things that I do, I think is also there's something I probably recommend is, especially now that we have this whole AI thing. There's a lot of startups coming up, especially those building, you know, conventional frameworks like, LangChain, Llama Index. We now have even, many of these things. They also have their own academy. So I think
Mhm.
sometimes you have this sort of best practices where it's kind of like, offer tailored trainings, or,
Mhm.
that fits in within how to use their tools effectively. So I also saw there's an astronomer guy who I saw the data talks up post this morning about learning Airflow 3.0, which I signed up for. I believe those who are interested in data engineering should take that kind of
Mhm.
course. Those who are interested in AI should look out for um, AI related courses, especially if you want to be a developer from a developer perspective, look out for the academy like Arise AI. They do have their own academy for those who want to learn how to do observability within the LLM space. Yeah, or take the LangChain Academy. They do have, I think, about two courses now around agents,
Mhm.
LangGraph, rest of them. So I think it's more like, for me, that's more like the best bet. And then there are a couple of resources too that are out there. One of the things that have helped me is, NVIDIA Deep Learning Institute.
Mhm.
Yeah, so they do offer courses around so thinking about especially around leveraging NVIDIA hardware. So
Mhm.
they try to like tailor their courses around you thinking about the hardware, thinking about best practices and also deploying. So I was lucky enough. So one of the mentors that I have just was able to offset that for me, getting me a coupon for one of their courses. Some of the courses are also free. Yeah, some of
Yeah.
the courses are free. Yeah, so they also
Mhm.
like very, very essential for those who willing to go
With
into it.
NVIDIA, I remember they often give coupons for free. So I remember partnering with them for they do this conference. I don't remember how it's called. They do it once or twice per year.
GTC.
GDC, exactly. And they usually want to promote the conference. That's why they contact people on LinkedIn with some number of followers. They contacted me too and say, okay, like here are coupons, you can share them with your followers. So I was doing that.
Yeah.
So yeah, just watch out. Maybe check socials from time to time.
Yeah, check socials,
They
and
might.
then they have this website for higher institutions. So they have this some of their courses, especially those special ones. They usually do it at certain times of the year. So you see the trainings that they have, and you can sign up free as a student. Just use your student email. So that has helped me a lot to take a number of their courses. Like the recent one I did was the conversational AI, building conversational AI application, deploying it using the NVIDIA name infrastructure,
Mhm,
deploy on the NVIDIA GPU hardware, be it A100 or H100, designing the whole Kubernetes,
mhm,
that's YAML5 templates and the rest of them, and then deploying. So these are very, very essential, especially for students who have an email address. Your student email address can get you a lot of stuff.
mhm. Okay,
Yeah.
yeah. There are a few questions. The first question I see is can we register for 2026 batch? The question is about data engineering course. I shared the link. It does say 2025 simply because I did not update the date. So you just sign up for 2025 link and it's fine. Yeah. But then we also have a questions to you, Danielle. So the question is, for a data beginner, what works in the field and how to even approach doing projects there? And I guess you were there a couple of years ago. So how did you approach being a beginner and starting to actually getting things done?
Okay, so yeah, that's a good question, but I'm going to answer it this way. I borrowed your templates, Alexei. So like I said, a lot of people in astronomy, especially for some of us coming from developing countries, don't even know how to code. So if you want to do a postgraduate program, that's when the whole coding team now because creeps in because automatically you need it, but then you don't have enough time to like learn the skills because remember you're already in the middle of your program. So I so with people that I work with here, I reached out to the BRICS Astronomy team here. So because astronomy, we have the BRICS Astronomy for the BRICS so countries. So they have their office here. So I reached out to the lead, and then I proposed that, don't you think we need to organize some sort of learning event for young people who are interested in astronomy? And it was like, okay, what do you want? I say, yes, I know there's a lot of summer schools, but most times the summer schools always center on the physics itself. So even when they are doing the Python,
Mhm,
they usually have especially for developed countries like America or Europe, they usually have the notion that you're already very good at programming, right? So we started this whole thing. I made the first proposal last year, I think around October or so, and was like, okay, this is a good idea. We're going to discuss it. And then around January, we finalized it and say, okay, a lot of people now came in. We have the institute here called IDEA. They provide a cloud service for astronomy. And then the BRICS Astronomy Group, and then other people from India, an institute in India. So we have two professors from there who teach computational astronomy, physics. So they were like, oh, this is a good idea for beginners in astronomy to say, so we called it BRICS Astronomy Data Analytics Program. So it was an 8 weeks program that is designed for those who have no background in programming. So it's a pure analytics. So you come in, you learn the process, you learn the coding process from Python, just beginner level Python. And then at the end of the day, so we also incorporated like assignment. So like I said, I borrowed your template. So doing
Mhm.
this, like making sure every week there's always a lecture, and then there's also like a presentation, hands-on that people need to do. And then at the end of the course, there was a project. So at the beginning of the whole thing, we also mentioned that people should share their resources online. So to be honest, my LinkedIn, that's why I say I don't know how you do this. My LinkedIn has been that's because we had more than 900 people sign up for this program
Mhm.
initially, and then in the course of this whole thing, a video is also there on YouTube
Mhm.
because I was the lead facilitator. So you're training people, they are learning, they come in because we have to do it two times, so morning and evening, to just make sure we can accommodate people either in the eastern part of the world or the western part of the world. So it was very, very successful, and they did a project. Like, you know what? You're just a beginner. Yes, maybe I encourage you to say, you know what, even if you just do it in a Jupyter notebook for now, in a Colab that is shareable. So I emphasize that they should make sure that they put the whole things in Colab, because with Colab you can share the link. People can see exactly what to do, even see the results. So they did that, and they were able to also tell the story, taking astronomy data for those who have astronomy background, or if you also, because there were a lot of people who were not like, you know, amateur astronomers who signed up for the program because they just wanted to use the opportunity to see how what is happening there. So we had more than 190 submissions of projects that we had done, and a whole lot of them got their certificates at the same time. They shared their learning things on them, and this program finished in July, around first second week of July, and about two three people have reached out to say, oh, they are so happy about this that it has helped them to even improve their what's it called again? Especially those applying for postgraduate opportunities. So you want to also show a form of projects that you've
Mhm.
done. You want to also demonstrate that you know how to code. You know how
Mhm.
to think about solving problems, taking the data, doing analysis, and generating results. So some of them did very things that were like, I was surprised, like, how did you guys come up with these whole ideas? So the
Mhm.
thing is, irrespective of where you are, if you're just starting, make sure you learn the basics. But while you are learning the basics, think about the problems that basics can solve, right? If your background, let's say your background is finance or your background is economics, and
Mhm.
you just learn how to maybe use pandas to read the data, and you learn how to do basic statistical analysis. The next thing should be to find an economics data, right? You already have some basics economic background. Use Python to do the same thing and share the results. Explain what you have done. It helps a lot. So at least people are saying that you have both the technical know-how in your background. You also have the technical know-how. I would just say scientific know-how or knowledge of your field, and you also have the technical know-how in terms of how to use tools to derive results. So, irrespective of where you are, just make sure you're doing that. I'm not discouraging Jupyter Notebook. When you start, you can also use Jupyter Notebook. Make sure the link is shared so that people, and put it on Colab, because with Colab, people can easily go open it up and they will see what you're doing. They will just explain the steps that you've taken,
Mhm.
that. Yeah.
Yeah. So basically, what works in the field, and your answer, if I may summarize it, is first focus on basics
Yes.
for machine learning. This will be Python programming, and then do projects. And for projects, what helps is having some sort of structure. So, for example, this is what we did in our courses. So say, okay, this is what is expected. This is the criteria we use for evaluating. So now for you, it's simpler to go ahead and implement the project. And this is what you borrowed, and this is what you used in your course. And you were saying that it works. Students were happy, and some of them found new interesting opportunities, right?
Oh, yes, of course. So, because this is a season where students are applying for like PhD opportunities, masters are coming out. So people are always applying, and then you also want to like, show strong motivation that you have programming skills, or at least in the area that you're interested in, that you've done something already, like maybe taking data somewhere and doing basic analysis. That shows that you already have a background. And it's they say seeing is believing. Yeah, so communicating astronomy is beautiful. I can say I know this, but when you now say, okay, oh, I was able to get this data somewhere, and I was able to do this, or because I was taking the data analysis project, it becomes like a plus for you as a student.
And then the same question actually has two questions. The other part is, should I focus on data engineering or data science slash machine learning? What do you think?
I'll just say start with data science first. Data engineering is it's a bit technical. So because you need to
It's more
understand
technical.
data itself initially before
Mhm.
going to because data engineering is more like managing data, provisioning
Mhm.
data, data warehousing. So understand what data is first. Yeah.
Mhm. But also it depends where you start. So if you start as a software engineer, then maybe for you data engineering will be easier than machine
Oh,
learning.
well,
So,
that's true. Yeah,
yeah,
I'm just answering from maybe I don't know the
yeah,
background, so just
like
to
you to yourself 4 years ago, right?
yeah.
Okay, yeah.
Mm.
There is also a question about my T-shirt. It says "Pip install DLT."
Yeah, I wanted
So
to ask you that.
yeah, it's a
I know
DLT.
DLT. Yeah.
It's a data load tool. DLT is one of our sponsors. They support Datadogs Club, and with them we did quite a few things already. So you can go and check our YouTube channel for. So they are a data engineering tool. Let's say you have some things that are, let's say, on S3, and you want to move them to BigQuery. You can easily use data load tool for that. Also doing some transformation and so on. So it's a very convenient way to build pipelines. So and because they sponsor our community, they are also Berlin-based, so they gave me this T-shirt, and I like this T-shirt. It's just a coincidence that I wore it for today's stream. I sometimes do that, but yeah, it's a very convenient T-shirt. I like it. But yeah, give them a go. And with that, we should be actually wrapping up. Maybe Daniel, last question to you. If anyone wants to learn more about astronomy and data science in astronomy, um, you mentioned AstroPy. Is there any resource for learning AstroPy?
Oh yes, there's just Google AstroPy Learn. It's a free
AstroPy what?
Learn AstroPy
AstroPy
Learn. Yeah. So
Learn.
there's a couple of tutorials on it. You will see how to get
I
started.
cannot quickly find it. Maybe
Learn
you can share the
AstroPy.
link. Yeah, AstroPy.
Yeah,
Type it.
so let me see. Learn.astropy.org. I'm sending it now in the
Learn, okay, dot
yeah.
astropy.com.
Yes.
Okay, please send it because like doesn't load for me.
Okay, so I've sent it in the chat.
It's .org, sorry, I wrote
.org. Mhm.
.org. Let me, yeah, I'm going to share it in my chat. Okay, okay, fine, I shared. Okay, Daniel, thanks a lot for joining us today, for sharing your story. I'm pretty sure it motivated and will motivate a lot of people, because I also want to use your story as an example why they should share what they learn in public. So thanks a lot for joining us today and for talking about astronomy, machine learning, and how you liked our courses. Thanks a lot.
Yeah, sure. Thank you to Alexei for like I say, pulling all that courses for free is not easy. And I hope I'm able to get sponsors for the next MLOps camp because I was worried when you said, oh, it's going to be the last if you don't get any sponsor. Because I think that course is
Yeah,
very, very essential, especially for anybody that wants to do AI, LLM related stuff. Because if you don't
yeah,
understand the whole concept around MLOps, you're going to struggle with the
yeah. With
LLM. Right. Yeah.
MLOps, it's sad that I cannot find any sponsors because all the companies that were doing MLOps, they're now focusing on more on AI products
Yeah.
because this is the hype is right now. This is where the investor money is. So many companies are focusing on this side, which means that for MLOps they don't have any marketing budget. And yeah,
I do understand
but
that, but I
let's
think,
hope with
but
this
but
situation changes.
The LLM ops too is there for people
Yeah.
to catch up to. Yeah.
But let's see, maybe things will change. I will continue reaching out to sponsors, even though I said it probably would be the last one. But if some of them says, okay, now we actually want to support the course, we'll just run it again and probably update a few things. So let's see what
Okay.
happens.
And final word is for those listening, please, the resources is freely available on YouTube. Even if you don't have the next one, just go there because I usually go there and consult things, time intervals. Just go there. You should bookmark it. I don't know if it's what's called in YouTube. Make sure you save them. It's something that you can always go to because the resources are freely available and the
Mhm.
tools are not necessarily changing because they are still there. They are not outdated. Yeah.
Yeah, we're not going to remove any content. So the MLOps course is going to stay on GitHub regardless of whether we will find sponsors or not. All the content will stay there. So you can just watch the videos when you want. Okay, that's it. Thanks everyone for joining us today. And thanks, Daniel. So it was fun. And